All right, we want to talk about section 8.3 today. Okay? The title is Infinite Series. Last time we talked about sequence. Today we want to talk about series. Now, what is a series? Okay, a series is just a sum of infinitely many terms. A series is simply just a sum of infinitely many terms, many numbers. So let me give you an example. So for example, okay, so 1, like 1 plus 1/2 plus 1/3. Okay, this is an infinite series. Okay, it's a sum of infinitely many terms. Or it could be 1 plus 1/2 plus 1/2 squared plus 1/2 cubed. The general term is 2 to the n. Okay, and it could be so it could be, for example, it could be just so that sine, okay, pi over 2 plus sine pi plus sine 3 pi over 2. So the general term will be sine m pi over 2. Okay, so any of this is a series. Each one of these is a series. Series is a sum of infinitely many terms. Sum of infinitely many terms. Okay. You cannot actually add up all those numbers. Because why? Because there are infinitely many terms. Okay, so even if you have a calculator, right, and you want to add up all those numbers, it takes you how much time to add up infinitely many terms? It takes you infinitely many times to add these numbers. Okay, so literally you cannot add them up. Okay, in theory you cannot add up all those numbers. All right, now there's a legend about this infinite series. Why do we consider this? Why are we interested in adding up infinitely many numbers? Okay, there's a legend about it. It is the following. Okay, you probably have heard of these kind of things before, but you probably have heard of similar to this. Okay, so suppose I have a person here. Okay, suppose there's a turtle here. Turtle here. Okay. Now the point is that this moving, okay, from maybe say 100. Let's say 1 mile, okay? And I'm here, okay? And then, of course, I mean, say even if it's 1 mile, I'm sure I can catch it, right? It's maybe 1 day or so if I don't walk very fast. Okay, I'm going to catch it definitely, right? But there's an argument that you can never catch it. That's very interesting. This type of argument happens many years ago. People were talking about this. Okay. So let me show you why you can never catch a turtle. Okay? So say this is 1 mile or something, okay? Now when I walk halfway to this, 1/2 of this, the turtle already walked, maybe slow, right? But some distance. So if I walk up here, turtles walk up here. Now when I walk half of this, say up to here, the turtle, of course slow, but also walk something, a little bit here. And when I walk half of this, turtle also walk a little bit, maybe slow, but some distance at least. Okay, so I'm half of this. I'm here, the turtle is here. Now when I walk half of this, when I reach here, turtle also walk a little bit. So the argument is that I can never catch the turtle because whenever I walk halfway of the current distance, the turtle is already moved a little bit. And I keep going on forever. And how could I catch it? But this is, of course, this argument is wrong. I mean, because if we do experiment, this everyone knows I'll catch it, right? So, but why I cannot catch it? But why this? So what's wrong with this argument? What is wrong with this argument? That's the point. There's something wrong with this argument. This kind of argument we call it paradox in mathematics. Okay, namely, we know it's wrong, but why this argument is wrong? Okay, so the argument. So where is wrong? The wrong is that when I add up infinitely many time here, infinitely many time, I have to get infinitely many time. So the paradox, so this thing is wrong. Wrong is here, is that the sum of infinitely many numbers is infinite. That's why this argument will show that no one can catch a turtle because of this argument, because the sum of infinite many numbers is infinite. The sum of infinite many numbers is infinite. And it is this argument that's wrong. That's why this argument looks right. This argument looks right because the argument here, this is wrong. Okay, so now the point is right now is how do we define the sum of infinite many numbers? If I have infinite many numbers like this, how do I define their sum? What's the sum? Because no one has the time. Nobody has the time to add up infinite many numbers. Because no matter how fast you do, say you punch the calculator, say even the supercomputer, there's always a time lag for adding a number, right? Because you need to push the button or whatever. And to add infinite many numbers, you need infinite many time, but nobody has infinite time. Okay, so therefore we have to define the concept of sum of infinite many numbers. What is this? What does this mean? Okay, so this is the argument of this section. All right, so let's look at. Well, if it doesn't matter, we'll talk about this. We'll show you what. All right, so I'm going to start with one example. Okay, start with one example. But before we do anything, let me give you definition. Okay, definition. You see definition. Okay, so suppose I have a series. We have a series. Now, when I say series, it always means infinite series. Okay. So I probably just don't mention this, but when I say series, it always means this. A series, I can always write it as this. Okay, because this is just like this. A sub 1 is this one, A sub 2 is this, A sub 3 is this, A sub 4 is this, A sub n is this one. Okay? And this, for this one, A sub 1 is this, A sub 2 is this, A sub 3 is this, A sub n is this, A sub 1 is this. Okay? So every series can be written like this. And for convenience, because we don't want to write so many words and so many symbols, we use the notation. I'm going to use, okay, normally we use this as notation. Okay, notation like this. Okay, so this will be say A1, A2, so on. Or the n doesn't have to start with 1. It can start with any number. Say start with 0. It's A0 plus A1. Well, n can start with anything, so maybe 10. I mean the n, so it's A10 plus A11 plus A12. Okay? Alright, so I'm going to define what is the meaning of the sum of this. Okay? So I'm going to do the following. Okay? So I'm going to let S n to be simply just A1 plus A2. So start with here, okay? Plus A sub n, only up to A sub n. A sub n. I'm going to give this a name. It says n's partial sum. N's partial sum. Okay, I'm going to give this name. N's partial sum means I only add from first term to the nth term. I'm going to give it a name. This is a name. N partial sum. So the definition is the following. If this limit exists, say S exists, then the definition, we define S to be the sum of the series. Okay, so A1 plus A2. Yeah, they define to be this one. Okay, I'm just defined to be this one. The S to be this one. So this is the definition of what's the meaning of the sum of an infinite series. And of course this. Alright, so let us now look at some examples of this. Okay, so I want to add up this series. I want to add up this series. Okay, so this is A1, right? A2, A3. Oh, yeah, that's fine. A3. Okay, so A sub n would be